Hello, I'm Andreas Nautsch and I'm presenting for the VoicePrivacy 2020 Challenge, the objective evaluation of the Privacy Zebra. So first I would like to start with a short recap on the EER, MinCLR and Zebra's worst case metric. Here are shown three synthetic score distributions. And what happens as first is an ideal score calibration. So bins are identified of similar error rate ratios, and according to these bins, the distributions are remapped to a unified scale. These are ideal log likelihood ratios, and in there we can then map the threshold for the equal error rate. We can also see that this varies across different score distributions, which in that regard is not good, because the decision-making proposition is that we first identify a threshold and then stick with it. The MinCLR describes in a generalized form class discrimination across all of these thresholds. And the Zebra's worst case metric just looks for what is the strongest strength of evidence in either direction. Regarding Zebra's expectation metric and MinCLR, this is motivated from empirical cross-entropy plots, ECE. And therefore, different prior probabilities, we can see relative information. And at 0.5, we can see a numerical equivalent to MinCLR. So if we take the computational metric for ECE, if this prior is a half, it's equivalent to MinCLR. But we can choose different priors, and with that, there are different interpretations. The prior is chosen, however, by the adversary. It is inaccessible to us. However, we can simulate for it. And if there's perfect privacy, that is the black profile in these ECE plots, then MinCLR is the upper bound. And also the profile is symmetric. In that sense, Zebra metric would exactly correspond to MinCLR. However, if the profile is not perfect, so as in the blue indicated here for a safeguard, then MinCLR does not need to be the upper bound, neither does the profile need to be symmetric. And these two metrics indicate then different things. And the expectation metric in Zebra is really the gap that we want to close between the blue and the black profile. If we look into the empirical results of the challenge, we will see MinCLR is often very close to the upper bound, and there's a lot of symmetries going on. So let's have a look. Here we see for the primary systems the performance across all data sets in the ECE plots, and we know that there are categorical tags to make the worst case metric better digestible. We can see that some systems are all over the place, and we see for some there's original data and there's improved privacy for the anonymized settings. We see that in many systems, the original anonymized scenario gives very good privacy preservation, where we have a domain mismatch for classifiers. And only when we have anonymized settings, there are just a few systems that grant for a particular data set that level of privacy preservation. We can see this on the population level metric for Zebra, that's the expectation level metric, and qualify systems there. And we can see this as well for the worst case privacy disclosure on the individual level. Again, we can use the categorical scale here, the categorical tags, which help us to better qualify between the systems. If we want to talk about metric correlations, so how does the Zebra population level relates to the equal error rate, we see nominal, they are the same trends, but there are differences if we look into the detail. We need to keep in mind that Zebra is based on a formal model, and while the equal error rate is kind of a safety evaluation, if we want to talk about security and privacy evaluations, we need to look into what we actually want to have. And in that regard, CLR-Min is reflective of a security evaluation, though there we see a strong correlation for the data on the voice privacy challenge. As indicated before, there are a lot of symmetries going on. If we discuss the two Zebra metrics, we see also that there are nominal trends that are alike, but they are, especially when we include the categorical scale, we can really see that in the detail, if we have, for example, a very low metric for the population level, we still don't know which category we are and how to qualify this. So for that regard, we need both metrics of the zebra to get the whole picture. Cheers.